So we want to jump in to introduce our speaker so that we can get started on the topic. So we're so fortunate to have someone that is actually part of us, a woman who could speak today and present today. Archana, she's data product manager at Women Who Code, and is a passionate advocate for women in technology. She's recognized as a fellow by the Python Software Foundation for her commitment to leveraging Python in AI and data science. She has delivered engaging talks at conferences like FOSS Asia, Women Who Code Connect, and Scipy 2023, and has a broad perspective on the role of AI and data across various sectors. She has experience leading a thriving community of Python enthusiasts as a Women Who Code Leadership Fellow. She's here to help you navigate and understand the complex world of large language models. So without further ado, Archana, over to you. Thank you.
Yeah, I hope you can hear me. Can you hear me, Chi?
I can hear you.
Okay, awesome. Thank you so much for the introduction, and thank you so much for presenting. I know it must be like really early or really late for you, so thank you so much for taking out the time today. And thank you so much for everyone for, taking out the time today as well. And so, yeah, let me go ahead and start presenting. Yeah, okay. I think you can see my screen now. Okay, awesome. So yeah, today I'll be speaking about so fine-tuning large language models. And the goals for this presentation is firstly, like, what you can take away from this presentation. I know like most of you are taking out maybe like a half an hour, 45 minutes of your time today. So I want to make sure that you come back with as much information as possible, and you take away as much as possible. So the goals of this presentation is to be able to understand the definition of fine-tuning, make decisions on when to fine-tune, know architectural choices for fine-tuning, and be able to fine-tune a model using OpenAI API. So that's what we'll be doing today. And again, like, to be honest, like why I wanted to do this study group is I realized that we have obviously Women Who Code Data Science host a lot of events, but there has been a lot of talk around GPT and large language models now, and I wanted to see like some form of these talks in our community too, because it helps to get that like it helps to make sure that we are talking about what is coming up and our community knows about it. Our community isn't left out. So that's the goal for me for why I want to give this presentation here. So yeah, let me go ahead and get started. But I want to make sure that this presentation is as I would say like as hands-on as possible. It's something that you also want to be involved with. So feel free to use the chat. Don't worry. Like I feel like all of us are on a learning journey. Even I did not know a lot of things when I started, and especially, by making these presentations, I'm learning more. So, just feel free to let me know your questions, and also feel free to chat, because I feel like the more that you get involved, the more that you will take away. It's like, I would say, like a typical class, the more you get engaged, the more likely you're to remember what happened, right? So yeah, let me go ahead and get started. So yeah, today's topic is fine-tuning LLMs. So just to recap on our last presentation, so the main takeaways that we had was about this paper called Attention is All You Need. I think it's like one of the most cited papers right now. Like I do believe there'll be other deep learning papers or like papers that will also be cited, for example, ImageNet. But Attention is All You Need is very, very famous in the NLP community right now and probably has a lot of citations. And yeah, so two main takeaways from that paper was firstly like what do transformers, or that is what like GPT is based on, really do. So they pay attention to different words. So in the sentence, and based on how they pay attention to different words, they actually guess the next word. And so another thing that's important from this paper was positional encoding. You need to have a structure to a sentence so that the model knows like the difference between the order of the words. So when it says I feed my dog dash, it shouldn't say stuff like cat food. So yeah, your model should be able to understand the structure of the sentence. So yeah, I just wanted to give out a quick quiz, and feel free to get as involved as possible. And today's presentation is, to be honest, very fun. I've tried to make it not so boring. I know, like, when you put a lot of technical terms out there, we lose people out. So my idea is to make sure that you walk away with some fun topics. So today's first question is, if GPT-4 were a chef, what would tokenization be in the kitchen? Would it A, be naming each individual cooking tool, or chopping ingredients into little pieces, or cooking an entire meal without tasting it? So what would it be? Awesome. Yes, it's B. You're all right. So yeah, it is chopping ingredients into little pieces. And just to recap why it is so, in case like someone couldn't pick it up, and that's perfectly fine as well. Don't feel bad if you didn't know the answer to this. Again, we're all learning here, so feel free to learn at your own pace, right? And so tokenization, when we looked at both RNNs and CNNs, which were involved in data processing, we realized like one of the main characterization or characters is the fact that you can actually break the tokens into different forms. You can break it into sentences with individual words or tokens or characters, and those are essentially called tokens. So if you see on the right hand side of your screen, it is like the GPT family of model uh, process text uses tokens. So if you see the colored thing on the bottom, let me make sure I have my tool. Okay, so if you see the colored thing on the bottom, it actually splits up the words, right? So, and it doesn't split it up necessarily into just words. It might be like, if you look at GPT in particular, it splits G and then PT. So those are like, G is a separate token, PT is a separate token. So that's what tokenization is. And why is tokenization important is that's how the model in essential views the sentence, the text that you feed it. And also it's important because you're going to come across this terminology a lot when people talk about this. And so you should know what it means, and it'll help you like read blogs and maybe read papers better. Okay, the next question is, what do you think is GPT's favorite hobby? Is it A, stargazing? Is it binge reading and guessing the next word? Or is it building Lego towers? Go ahead and guess it. Awesome. Yeah, it's B. It is guessing the next word. So, I mean, a fun way to remember what GPT is basically doing is all base models are basically doing is that you take in the words and it's trying to guess the next word in the sentence. And that's all it does. Okay. And one second. Oh, I think I missed that. Okay. Okay, so if you imagine if you were at a party, what do you think GPT-4 base model will be the best at? Will it be A, completing your half-told stories, or B, like performing the latest TikTok dance, or serving the best, dishes? Yeah, awesome. You folks are amazing. So it is completing your half-told stories. That's what GPT is good at. And I recently came across this thing. I don't know, I was reading it on Twitter, and people said it's really good at imitating the way that humans write. And I think that's what makes ChatGPT so exciting, because the way that it writes sounds closer to how we write as humans. So yeah, and just one thing I wanted to recap about is uh, what does an LLM basically do? It'll actually like end up imitating the next token. So when we looked at this wonderful example of population of India is what times the US, what it basically does when we go through it, we do it logically, where we try to compare the two population and then divide it to know the integer or the value. But over here, what it's doing is that it's just trying to look at the sentence as tokens, and then it's spending the same amount of time on each token. And then because it has a very large memory and knowledge base, it's utilizing that um, to end up like, coming up with the answer for this. And yeah, so what are base models really good at? So base models are really good at completing tasks, right? It can be prompted into completing tasks. So, and base models are not assistant. So this is like, I would say before stuff like, uh, before we had like GPT, like chat GPT assistants. So before that, you had base models. So base models were like the pre-trained models, and they were really, really good at, completing the sentence. And what they basically did is they tricked it into performing something called prompt engineering, which we'll cover in our next session. Like we'll talk about prompt engineering in detail, but all you need to understand is they trick the model into performing tasks around prompts. And so, yeah, I just want to also recap the LLM pipeline. So if you remember, this is like a typical MLOps pipeline, right? Like the first is data ingestion. So you have like data input and you make sure it's the right version. And then you move into data validation. You make sure the data is right. And then you move into data pre-processing. And then you pre-process is as simple as removing any noise from the data to removing any null values and so on. And then you move on to model training, and then model tunning, or model like, sort of processing here. And then fine tuning. I think it should say fine tuning. But okay, so yeah, such model like fine tuning. And then you also have model analysis here, model validation, deployment, and model feedback. And so this is what we'll focus on today, is only the model training and fine tuning part. So let me move on to GPT assistant training pipeline. And this is something that I took from this person's talk called Andrej Karpathy. He's the co-founder of OpenAI. And he has given this really nice talk about, I don't know if you had a chance to go through it. I know it's a pretty long talk. So if you are like going somewhere, then catch up on it, or trying to listen to it as a podcast, that will be great. And he talks about the state of GPT. And this is where he talked about what was going behind chat GPT and the GPT assistant training pipeline. So you obviously have pre-training, which is what we talked about previously, if you remember. So pre-training, what it does is it uses firstly like huge amount of compute, right? So if you look here, thousands of GPUs, months of training, and so probably like OpenAI through whatever compute they had to do this, right? And they basically trained it on the raw internet, right? And so trained it on like trillions of words. And they might be like low quality, because obviously when you look at internet, it has so much of data, right? So like low quality and very large quantity. And here we have the base model, like the person partying, it'll just try to guess the next word. And that's what the base model does. It helps to complete your untold stories. And so yeah, to recap, we use the data collection. So the data collection here was, Common Crawl, C4, GitHub, Wikipedia, books, archive, Stack Exchange, etc. And then over here, like what we realized, one thing we realized is, wait 1 second. Okay, so when they were training GPT from scratch, and this is a very interesting use case I found. I think New York Times did it. So they tried training a GPT model from scratch. And if you remember, what happens is you feed it like a Shakespeare, you try to make it like do a Shakespeare poem on its own. And how does it end up doing that, right? So when the first few samples of iterations it's really bad. It can't make sense of words. And then like you can look at it here, after 500 iterations, it says for, but, to, Acer, etc. And after 5,000, it starts saying something that sounds a little more like Shakespeare, but after 30,000 iterations of training, means that many times the model has just run training alone, it actually ends up sounding a lot closer and better at being Shakespeare, or like sounding like Shakespeare. So yeah, and one thing that you would all the time come across is this thing called loss, wherein like it's just a fancy way of saying that, I want the um, model to be as error-free as possible. Like if it's sounding like Shakespeare, it should sound as close to Shakespeare as possible. And that's all you're doing here. And that's why you are like all of these graphs that go down, like, this nice slope that it has. And so these graphs just show the fact that the loss is reduced over time, which means the model is performing well. And yeah, so that was pre-training. And then today we will like look into something called supervised fine tuning, which is the next task, right? So supervised fine tuning is, we move away from going into base models into it becoming actually good at some task. And I'll go across why you need to do fine tuning. But I think it's very important once you actually start using these models, right? I mean, like, obviously you can interact with GPT today, but you want to go beyond that, right? You want to create your own applications. And what's going to happen is, like, for example, you're at your place of work, or maybe you are at doing a research project. It's going to come again and again because you know that you have this very large language model which has learned a lot, which is a huge memory as such. And people want to leverage that. And when people want to leverage that, they are going to move towards fine tuning. And that's what we'll be talking today. And if you remember, we also tried to try out other LLMs and see the difference to GPT. We tried out with Coher and others. And yeah, let me move on. And if I have time, we can go through that again. So what takes a base model to be assistants? So that's what we're going to be talking today. Like, why are they good at being assistants? And one of the things is we move towards something called supervised fine tuning. So supervised fine tuning is where you have like ideal assistant responses. So now you have humans being involved. And you have, one of the things you need to realize is you have lesser compute. Previously, if you had thousands of GPUs being used, now you have like 100 GPUs being used, which is still a lot, but still way less than needed in the pre-training stage. And now the model is still predicting the next token, but what it becomes good at is specific tasks. And that's what we will see today. And yeah, feel free to post your questions in the chat or in the question and answer. I think Yuka asked a question. Is this about how to actually train a pre-trained model? I think training a pre-trained model is much more, I would say, extensive. Not about the fact that you can't do it, but it's more like you would need a lot of compute to throw at it, because models as such need if they're, for example, trained on a lot of internet data, which that means that you have a very big model with you. So there's no way we can recreate a pre-training model, at least with the compute we have. But yeah, we can understand how they did it and then fine tune. So I think all the magic happens with fine tuning, and that's very important because that's exactly what you need to be pitching and what exactly you need to be doing now. You can't really like try to build your own LLMs, but what you can do is fine tune it on the tasks. And
Sorry, if I
yeah,
can jump
sorry.
in.
Yeah. Please, yeah.
Yeah,
I'm
if I
sorry, I
can jump
forgot to
in.
introduce Soham. Yeah,
No worries.
Soham is also doing the presentation today with me. And I'm so sorry I forgot to introduce you. Please go ahead and introduce yourself, Soham.
Yeah, no worries. So hi, I'm Soham. I work as a lead ML engineer at a fintech startup in Singapore. And yeah, we have a few LLMs in production, and I know kind of like the challenges that you face when deploying these. In terms of the question, so ideally when you train a model, you want to train it to be as generalized as possible so that it's good, but it's not great or like outstanding at a wide variety of tasks, right? And then the next step that you do is fine tune it to the domain or the task that you're working on. So when you're training a model, you want to feed it like a wide variety of data, something that not everyone will have access to. Even if you disregard the huge amount of compute that you need, you may not have that much data to actually train the model. But so it's easier to actually like fine tune a pre-trained model than to train your own model from scratch and expect it to get like similar performance. Yep, thank you.
Yeah, awesome. I think we also have a question from Ella. And again, like, thank you so much for posting your questions. And I encourage you to post more questions. I feel like, both me and Soham, and we've been like doing this, but we end of the day, we also have a bit of tunnel vision where we only see things that we want to see. So your questions actually open up doors more than you realize. So Ella asked, what's the timeline of the chart for each column in the training pipeline? I mean, each column is happening separately from other column, and in separate time for the model is finally created. So I would say like it's more like it's following one after the other. So I genuinely think it would have taken OpenAI a long time to even train GPT-4. And so yeah, it's mostly happening one after the other. Pre-training happens solely on its own, and after that you're doing things to actually make the model better. And correct me if I'm wrong here, Son.
No, that's correct. So you usually do them one after the other. Yeah.
Okay, awesome. Yeah, please keep the questions coming, and thank you so much, everyone, again. Let me go ahead into fine-tuning. Oh, no. Okay, awesome. Okay, so fine-tuning LLMs, right? Let me minimize this here. Okay. So yeah. So imagine you've spent like a lot of years learning various languages, right? And throughout the presentations, I'll be giving you small examples to make sure that you're able to understand what this is. So imagine you spent a lot of years learning various languages. You've practiced like speaking and writing in English, Spanish, French, and many more. And you've become great at recognizing the rules of grammar, the flow of sentences, and the meaning of words in these languages. And this is similar to how LLMs are initially trained. They process and understand vast amounts of text data from diverse sources and learning the patterns and structure, nuances of human languages. And so, like you with multiple languages, LLM can generate text that makes sense in various contexts, right? But let's say you want to work as a tour guide in France. So you might need to understand like French culture, history, colloquialism, and that you also need to learn that you didn't learn just to speak the language, right? And you'll need like additional training specific to this job. In a similar way, although LLMs can generate general text, they may need to be fine-tuned to perform specific tasks or understand specific domains. So, understand, like, for example, the model learned everything about all the languages, but now it needs to understand something very specific to the French culture to be, or like, to France as such, to be a tour guide, right? And so why fine tuning? So like consider the French tour guide thing again, like the same use case. So you have these language skills, but now you need to become like the tour guide. So how do you learn the necessary information and skills? You can read books on French history or take a course on French culture or spend time with the local to pick up on colloquial phrases. This specialized training would be similar to fine tuning on LLMs. And so fine tuning is like so fine tunings we have also done like fine tuning before, like it's not new to I would say deep learning. We have done it before with like ImageNet and stuff as well. Like when you end up like doing it for computer vision task as well, you actually like do this thing called transfer learning, and somehow you can also like give parallels to it, like wherein like you take like a specific data, like your data is again, like as Som said, it's general, it knows everything about everything, right? But it doesn't know specific things about like for example the French culture. So now you like sort of fine tune the model and on a specific data set relevant to the task in hand. And this might mean like training the model on, for example, medical textbook if you wanted to understand and generate medical related text. And this additional training allows the model to perform better on this specific task, as it has now learned nuances, vocabulary, and important features of this domain. So yeah, I think like last time I had this fun example of understanding, how if you are like out of the university, you are trying to become like a medical student, then you would do like a specialization in medicine. So it's something similar to that. So back to your job as a tour guide in France, why couldn't you just start working with your general language skills? Well, you might misunderstand a question about French history or give inappropriate answer about local customs because you learned the basics of the language and not the specifics of the culture. Similar to that, an LLM has not yet been fine-tuned, might not perform well on tasks that require specific knowledge or understanding. And so, yeah, this is why we need fine tuning. Fine tuning is essential when the model task involves a specialized field, sensitive information, or unique data that is not well represented in the general training data. And that's another thing, right? Like, I think that also, I think opens the door for discussions, right? For example, with GPT-4, we don't really know what it's been trained on. We don't know if it's been trained on some domain more than the other. So I think in those cases, we have to do fine tuning because we also don't, like technically they haven't open sourced it. So we don't really understand like what they have trained it on, which means when you actually end up using the model, you will have to fine tune it because you have to assume that, okay, what if it doesn't know some like the thing that I'm working on? What if it doesn't end up knowing well? And, for example, right now, I think it only has data till 2021, which makes it like, which opens it up for so much data it hasn't seen. So you have to end up fine tuning it for your own task to make sure the LLM performs better. And okay, so now this is a very important question, right? Like when to fine tune LLMs. And I think you might be thinking that, I mean, like, I really need to perform fine tuning. And I think that's very important as well, because most people jump onto the task. They're like, okay, let me go ahead and start fine tuning. But I want to also make sure you take those design choices. And why this will help you is that when you're building your own, right? And when you're deploying your own, you have to make sure that your LLMs, like, or your, like, what models you're deploying does that task well. And to make sure of that, you have to, like, there's a process of trial and error, right? And to go through that is what we will be doing today. We'll be understanding what are the ways that we can finally come to fine tuning, right? Like, what are the other things that we can try before we can try fine tuning? So understanding when to fine tune LLMs involves various factors as such, like your use case, the cost, and your desired level of domain expertise. So let us start with something basic. Let me push this back. Okay. So this is the case of for closed APIs. So a common starting point for considering applying LLMs to a specific task is using APIs. So like ChatGPT, right? So GPT gives you like a GPT-4 API, like it has like a few models that it gives you. So like it has like you can perform tasks such as summarizing documents. So you would have seen this very fun, I guess, PDF plugin now, ChatGPT plugin. So what it does is it helps to summarize these PDF documents, helps to answer questions around it, or maybe serve as a chatbot, you know, make sure the models provide the satisfactory results. And like maybe that does your does your job already. So the affordability of using these closed APIs should not be underestimated. While many people believe hosting open source models is cheaper, the operational cost of hosting infrastructure in the long run can outweigh the cost of API per call. So, you have to sort of do your own cost benefit analysis there. Like you have to figure out if, making these API calls, how many API calls you really need to make. If it's less, then you can end up using APIs only, and that should probably do your trick. You don't need to get into fine tuning. But if you think it needs to be much more better at what it does, then you need to move forward. So I would say like this is close to like, a good term, like good way of explaining it is, imagine like you're baking a cake for the first time. You could either create it from scratch, like you could opt in, or you could opt in for like a pre-cake mix, right? And the cake mix is easier and quicker option, which will give you a decent cake without requiring too much baking knowledge. In the context of API, like AI or like LLMs, using APIs like ChatGPT is similar to a pre-made cake mix. These models have already been trained and are ready to use different tasks like summarizing tests, answering questions, and so on. And okay, now comes another approach, right? Like, for example, the first one didn't work, it still doesn't give you a good result. So you go down to this thing called document chunking and database approach. So for larger data needs, such as querying thousands of documents, and there's like, when you have like thousands of documents, you need like the model to like have, for example, more context length. You need the model to have like a better understanding of this document. So then you need to like have an efficient way to utilize databases along with closed API. This involves breaking down large documents into smaller chunks and storing them in databases. When a question comes up, the document chunks relevant to the query are identified by calculating the similarity between question and each document chunk. And this method overcomes the input and output limitations. Like, for example, GPT having only like 4096, I think GPT-3, if it's not wrong, having 4096 token limit. And so it can provide like satisfactory results when the answer is directly available in the stored document. So you end up taking this document and you end up breaking it down into chunks so that GPT can understand better. So now imagine you're having a large book and you need to find information on a specific topic. So instead of reading the whole book, you could break it down into chapters or even pages and only read the parts that are relevant to your topic. So yeah, so in similar to that, this is like called document chunking, wherein like large documents are broken down into smaller chunks and stored in the database. And when you need information on specific topic, the model looks for relevant chunks, similar to how you would only read the relevant chapters in your book. So yeah, and now we come closer to the fact that, okay, you've ended up chunking your document, it still doesn't work. What do I do next? So, and like, believe it or not, I mean, like, I mean, when I'm thinking about it, and if you are also like listening so far, you would be like, oh, I mean, like, would I really need to go to the next step? It will probably solve my problem. But when you actually go to real world use cases, you'll sooner or later realize that, you know, your models are lacking. It will not do everything you want. So you need to really try a lot of things and probably end up like fine tuning your model. So that's where we need to go down this path, so that next time when you make those design choices or make those architectural choices, you have all the information you need. So the need for domain specific expertise, right? What is this? So however, close API and database approach might fall short when expert perspectives are needed, such as speculating on complex topics like the financial outlook of the US economy. ChatGPT, while being versed in multiple subjects, may not be able to provide the rich domain expertise as a dedicated expert. So in these cases, fine-tuning an LLM becomes beneficial. So fine-tuning involves training an LLM on a specific data set related to the domain in question, enabling it to understand generated text that resonates with the expert knowledge in the field. So a good example of how I would say, what does this mean is, let us say you're interested in a specific topic like the future of the stock market. So like reading a general book on finance probably won't get you there. You would need to, you know, read a book written by a stock market expert. So this is where fine-tuning an LLM comes in. So it's a general model, but now you're giving it like a master class in a specific subject. So that's what it means, providing it like with expert responses. And finally, we have like, you know, maybe you fine tune the model and it's still not working. And someone asked that, right? You know, can we do pre-training on our own? And yes, you can train an LLM from scratch. And this is something that we talked about before, like this fun thing that New York Times did about, you know, understanding how to write like Shakespeare. And what you need to understand is, yes, you can do it, but it's very, very computationally expensive. So you need to make sure you have the cost for it, like you have the budget around it to do this. Because yeah, I mean, like, if you're, for example, doing it on the cloud, it can be so expensive. And as well as like doing it on, you know, on your own, like buying a GPU is out of the question, because I don't know, can you actually possess that many GPUs to do it? And would you have that much time in hand? I think time is also a huge thing. I mean, OpenAI would have trained their models like at least for 6 months before it got to where it is right now. And so, yeah, I think like if you have those things, resources in place, like money, time, then training an LLM from scratch is not a bad idea if you want to try it. So this is a nice flowchart I built into when to come into training your LLM. So in the end, obviously, it comes into training an LLM from scratch. So this is like, you know, do you have a specific use case? Yes, so, or no. So if it's no, then you end up like using pre-built models like ChatGPT. Like, you know, you don't like ChatGPT based API. So you don't like really look into building something specific. But now if you require specific domain expertise, like yes or no. So let us say yes. So then you have like significant amount of domain specific like data to train the model. If no, then you seek to collect and acquire more data or resort to a pre-built model or document. Yes, then you do have the resources, time, money, computational to fine-tune or train from scratch. Then go ahead and fine-tune the model, or go ahead and, you know, train it from scratch. No, then try to optimize resource usage by considering using pre-built models plus using document chunking and so on. So this is like just a small flow chart. It helps you to, I guess, like put together what I said in the last few slides. And I'll take a moment here. I know I've been speaking forever. So I'll take a moment here to just look at the questions. And if you have more questions, put it up. Please go ahead and ask again and again. I encourage you because, you know, this is a bit of a heavy topic. So I want to make sure I'm breaking it down for you folks. Soham, do you want to take the questions? If you're free.
Yeah, sure. Thank you. So one of the questions I see here is how do we strike a balance between fine-tuning and having a generalized model? Yeah, that's a good point. And that is actually a challenge that that people are facing in the industry right now. I saw a paper, for instance, released recently that showed that if you fine-tune a model too much, then the model tends to forget the general knowledge that it learned, and that kind of reduces its performance. Um, and I mean, that's kind of like an intuitive, it's an intuitive results, but at least someone, did the research and found out that it's actually true. And another challenge in LLMs is that, and it's a bit weird, but it's that the more you train it, the performance, it kind of tends to drop a bit, but then it comes up again. And this is in contrast to like smaller models where if you train it more, then what happens is the model starts to overfit and perform like worse on your testing set. So these are some of the challenges with striking a balance between fine-tuning and also having a generalized model. What we do in our case is we have a set of test data, for which like this set of test data is like very important for us, and our model needs to get this correct most of the time. And we train our model until the performance starts to drop like a lot on this set of test data, and that gives us kind of like a good benchmark on when we should stop fine-tuning. I'm sure there's other techniques out there, but I think that's one that works pretty well for us, and it's also pretty easy. Okay. The next question is there any specific standard to select number of iterations? No, there isn't. Those are the hyperparameters like, iterations, batch size and all. You'll have to kind of do experiments and vary them and see how your model performs. The good thing with these really large models is that the performance doesn't vary much when you select different, like when you make small changes to these parameters. So for instance, like batch size or something, it's okay if you don't, select the best batch size. At least if you get pretty close, then it's okay. In terms of number of iterations, that's something where you need to keep testing with your test data set and check to make sure that there is no performance drop.
Sorry, I was
Okay.
going to point your attention to one of the questions that was before these two questions just answered. Someone wants to know, one page in why fine-tuning has an image about transfer learning. Is transfer learning one of the common techniques in fine-tuning? That's one part A of the question. The second part was also, what's the difference between transfer learning and reinforcement learning?
Yeah, sure. So transfer learning is a kind of fine-tuning. So what we do in transfer learning came from computer vision and CNNs. And what we did in transfer learning was we had this model that was it's kind of similar to what's happening with fine-tuning in LLM. So we have this general model that's trained on a wide variety of image data. And then what you do is you have your own problem, which could be something like, I don't know. So me and Archana, we worked on a project for medical pill boxes, right? Which is like data that the original model never saw before. But because it had this general idea of what objects look like and what features to look for in images, it was able to transfer that knowledge, like that general knowledge, into the specific domain of medical pills and medical boxes, right? So that's what transfer learning is, and that's very similar to how fine-tuning also works in LLMs. Transfer learning and reinforcement learning, they are like completely different fields altogether. Reinforcement learning is what you might it's like models that try to iterate on its own, like by playing against itself and like trying to become better. It uses like agents, and you usually see them used in games or in playing games, or like stuff like let's see, like brokerages, and like two models trying to bargain with each other to get like a good deal, stuff like that, where you need to play against and mostly in games basically. Is Hugging Face a go-to resource for pre-trained models? Yes, Hugging Face is one of the largest model repositories, and most people who train these models will have their models hosted in Hugging Face, from where you can download them and use them. Is fine-tuning all that is?
Sorry,
Is fine-tune?
I was thinking because in the interest of time, do you want to first go over the demo, Soham, and then we sort of come back to the different types of fine tuning? Because I think if I go down that path, it'll take easily like another 20-25 minutes. I don't want to take that time up. If possible, we can shift it. So probably you want to just give the demo so that people can just and like give them the hands-on experience so that they can also understand. And again, like keep your questions coming. We'll go ahead and answer it right after showing you how to fine-tune a simple model.
Yeah, sure. Maybe you can stop sharing your screen and I can share.
Yeah, can. Do you also have the Jupyter Lab link? I can just drop it here so other
yes.
also
Sorry,
open.
give me 1 second. Let me just share
Yeah,
that.
sure. Let me just see the questions. Okay. Okay, I'll just answer the first question. Is fine-tuning all that is being done in all recently published APIs and apps fine-tuned to be better in the specific domain space? It's aimed at to solve problems or pain points user face. I think that's a very good question. I feel like, not all the models are same. Some models like GPT are obviously better. They've gone through the process. But previously we also talked about some Hugging Face model like GPT-2. So GPT-2 would be like a base model. It's not an assistant model. So that wouldn't have been fine-tuned. It's more like a base model. So I think it's really specific to models. Yeah, there are better models that have been fine-tuned, but there'll also be, you could still do more fine-tuning, That's something that will oftentimes happen. If you work on something, you will have to end up fine-tuning because you want your model to learn that data better. And yeah, feel free to jump in here if you want, Soham.
Yeah, no, I think that makes sense. So yeah, so for the demo, so what I've done here is I've used OpenAI to fine tune one of their models. So me and Archana, we've been trying to learn more about developing LLM applications and deploying them. So we actually created this small project called Speaker Scribe. And what it does is so because we give a lot of talks everywhere, we are trying to use LLMs to generate talks and like talk proposals, so talks, workshops, stuff like that. But the idea behind but then in the models that are out there right now, they're not really good at generating. I mean, they're good at generating talks, but they could be better if we gave them context about previous talks and talks that got accepted, so that it can generate these proposals better. So that's what I wanted to do here. I wanted to take a model, like a pre-trained base model in OpenAI, and try to fine tune it with some talk proposals that we got from PyCons. So what you need to do first is you need to install the OpenAI package, And we'll just use two packages. We'll use pandas to, get the data, and we'll use the OpenAI package. So we have a list of talks that Archana scraped. So you can see we have the talk name, the talk description, and then the type of talk, the talk category, as well as the level of talk. So I wanted to keep things simple, so we won't use all this extra metadata for now. We'll just use the talk name and the talk description. So what I did was I dropped all the extra columns, and I renamed the talk name column to prompt, because that's the prompt that the user will give. And then the description is what the model should ideally complete, right? It should be, that's the output that the model should give. So that's pretty much it. That's all the data pre-processing that you need to do. After that, what we need is to get the OpenAI API key. And this is something you can get from OpenAI's account. And when you create a new account, I think you get like $18 or $20 worth of OpenAI credits, which is more than enough to deploy a sample project, fine-tune a few models, stuff like that. So once you have your OpenAI key, you can set that as an environment variable. And then what we need to do is we need to prepare this data that we created into the format that OpenAI wants. So OpenAI has a command to do that, OpenAI tools, and then fine-tune prepare data, and then you give the file name. It'll ask you some questions like, do you want an end suffix to all the completions, which ideally you should use. Now we're generating talks, so we don't really want extra white space characters, and also that's why I put no, stuff like that. Yeah. So once this command stops running, you should see a .jsonl file. And what you can then do is call the fine-tune, like the create command of OpenAI to create a fine-tuning job. And you can create a fine-tuning job with different kinds of models. For me right now, I use their smallest model so that it runs fast. So I think the smallest model is Ada. And then they have a slightly larger model, but it's still small compared to like GPT, called Curie. So you can specify the type of model that you want to fine tune. And then once you run this command, OpenAI will give you a job number. And using that job number, you can check the status of your fine-tuning job. So you can see I started it yesterday night, and it took about 20 minutes to fine-tune the model. You can see that before me in the queue, there was 4 other people also trying to fine-tune some model. And the fine-tuning costs for me for this fine-tuning model was 2 cents. So once the model is fine-tuned, you can see it fine-tuned it for 4 epochs, which I think is the default, and I think you can change that. It'll return you to you the fine-tuned model name, which you can then use to send a query. So for instance, I fine-tuned 2 models, so one Ada model and one Curie model. So here is like how I called the Curie model. And the prompt I gave was introduction to Python. And you can see it started generating a talk. Now the Curie model, it's like a really small model, doesn't really work that well. So that's why you can see that the talk that it generated is also not that like good. But I think if we fine tune like a larger model, like GPT-3 or maybe even GPT-4, then we would have gotten much better results. Yeah, I think that's it.
Yeah, thank you so much, Soham. And yeah, I'll go back to presenting. Although I think it'll be good if I just take questions for now. Let me see. 1 second. But yeah, could you
We have
take
3 questions. I can read them if you want. So
Oh, thank you
the
so
first
much.
one is, I'm working in an organization where they have lots of data of patients in a tabular form containing numerical and also text formats. What are the common LLMs that could be useful to apply on that data to build any predictive or classifier model?
Yeah, maybe I can answer that. So I mentioned before, I work in a fintech where a lot of our data is also in tabular format. So there's models that are specific for tabular data. I can't recall any at the top of my head right now. But you can also use like GPT-4 for tabular data as well, and that's also something that we do. So for tabular data, ideally what GPT-4 doesn't have like a really huge context length. So ideally you want to break apart your table into small chunks, that has the context that you want to give to the model when giving it a query. And then like give it that small chunk of tabular data and then ask it a question on that. That works pretty well for us actually.
Great. And then another question is, so in fine tuning, I think you brought up something about fine tuning, and so somebody brought up the parameters earlier, but do you modify parameters of the test data or from the validation set? Because I think you mentioned the test set, right? And do you always split your data into 3? So training, test, and validation. That was the question.
Yes, you definitely should split your data into training, testing, and validation. And no, I don't modify any of the parameters when testing or validating. Ideally, you want to keep it the same. So because yeah, you want it to be standardized across training and testing.
And I think the question more of is in fine tuning, when you're changing your batch, your epoch, and so on, you mentioned on the test set. So is it on the test set or the validation set?
So when you're testing, you don't change any of the parameters, right? Because when you're fine tuning, when you are like training a model, that's when you can play around with the batch size and other parameters. But then once you're done training your model, you usually freeze all those values and then you run your testing data on it.
Okay, that we have only 1 minute left, but lots of great questions. I think we just keep going with the questions here. So sorry, guys, we may go over, but I think it's great that people are engaged and enjoying the conversation. So there's 3 more questions. I think we should just go through them, right? I see epoch there. I'm assuming that's in that I'm thinking that must be in the demo that there was epoch. Question was, how do you pick the value of epoch and what's the good default? And I think it's also kind of tied into that thing of changing the parameters and so on. So maybe you can talk about that.
Yeah, there's no good value for epoch. It's like something that you have to play around with. And how you and what you need to do is test your data. Like keep testing your model after each epoch. Just test your model on your testing data and see how the performance is, and that's how you know what a good like. And if the performance drops, then you stop training, and that's your epoch value. So yeah, so there's no good value for epoch, unfortunately. No.
And then so I said 3 questions. Sorry, one was just telling you thank you. The next question is, I'm trying to build an AI tool which would provide programming feedback for students. Is this a good idea as GPT already does it? But can it be enhanced, I guess? I'm thinking of using LangChain.
Yeah, so good question. And that's a question me and Archana, we asked ourselves as well when we were building the speaker scribe demo that I showed you. So yeah, we were wondering the same thing, right? Why do we need to build this if ChatGPT does the same thing? And the answer is that ChatGPT is like a general model. It may have seen a few talk proposals, but it hasn't seen like the good ones, or it doesn't have it does, let's say you're asking it to create a talk about something very specific in Python, right? The chances are the ChatGPT hasn't seen a lot of data about that. And so why I think you should go ahead and try creating what you want to create, even though ChatGPT can do it, is because I think you can make it better by providing more information, more context to the model, and maybe even fine-tuning the model to make sure it performs better. So yeah, it's the difference between having like a generic it's like, buying like the example that Sana mentioned, right? You can either buy a cake mix and yeah, that'll get you like a good cake mix, like a good cake, but ideally you want to create a cake on your own, right? That'll make it better. Yeah.
Yeah, I think like we would wrap it up here, but feel free to check out this. So we have been making sure we put the slides and the content into like a good blog format. And there's like a bunch of slides I did not cover today. I didn't like account properly for the time. But yeah, I was going to talk about types of fine tuning as well. So just feel free to check it out on the blog. It goes through different types of fine tuning now available. And as usual, I've put in like really interesting like examples like so it's easy to understand some simple examples so that you can go through it. And we also put up like you can go check it out. So I think it's already up, but how to like when to fine tune models and what do you need to do. Do you need to, if you have like a large data set, then what do you need to do? If you have like data set that is significantly different from the pre-training data, then what do you need to do, and so on. So go check it out. And yeah, feel free to reach out to us. I know we won't be able to answer all your questions, but again, please reach out to us. We would love to answer your questions. Put it up on Slack otherwise, and we'll come there and answer the question for sure. Thank you again so much, everyone, for taking out the time today and listening to us. And I hope we can see you in our next session. We're going to talk about prompt tuning, and that's going to get us closer to what is GPT, right? In terms of being an assistant. So please do come back and, learn with us. And again, like we're really excited to have you here.
Yeah, there's just two kind of questions that came up here. Someone's asking about which channel in the data science Slack to share their projects, the GitHub repo. So that we can find help on what she's struggling with the fine tuning. So maybe somebody can pop an answer for the person. And then the last one was yes, we'll get you the video recording of the last session. And do we have the CSV file that was used by the Google Colab? If we have that CSV file, can we share it? That's the other.
Sure. I think I can put it up somewhere. I will drop in the link on Slack. So I think you can use like, I think there's a help me channel or something. So maybe you can use that and, we will follow up there and we'll try to put it up on Slack, the CSV file.
Thank you so much to everyone for joining us today. I really enjoyed this session. I hope you did as well. A big shout out to our speakers. Thank you so much to both of our speakers and those that help with moderating. Lindsay, thank you for helping with moderating. And this was a really fun session. Thank you, everybody. And see you in the next one. Please be sure to join back again next week, Tuesday, depending on where you are. Maybe Wednesday for you, depending on where you are. But see you next week.
Bye-bye.
Thank you. Bye-bye.